Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. We are going to continue our lecture on project planning, but today's topic we are going to learn about critical path method. Critical path method is based on activity on arrow. So what does it mean by activity on arrow? If you look at this diagram, this network diagram consists of node and arrow, which is activity A, which is prepare the house plan, starts from node 1 and ends at node 2. And the arrow is from node 1 to node 2. Activity A requires 4 days to complete the project. Continue from activity A is activity B. Activity B is construct the house. Activity B requires 58 days to complete the activities, and it continues from B to C, C to E, and D to F. And the project completes when activity E and activity F completes. So if you look at this diagram, it shows that this network diagram in a loop. It has to be in a loop. Okay, this is another simple example of a critical path method or a network diagram. Okay, for a network diagram, the critical path method is the longest path in the project schedule network diagram. It says here that it shows in this diagram with the red arrow. The red arrow. This is another examples of network schedule diagram, which consists of several activities, and as you can see here, the red colored arrow represent the critical path. Critical path is the longest path in the project schedule network diagram. It means that after consider all the activities and the duration, the critical path is the longest duration of this project. And critical path also establishes the minimum project duration. What it means is that the project, for this project, after considerate all the duration plus with the critical path duration, the project able to finish at the minimum duration. And for a network diagram, a critical path can have more than one critical path. Okay, I'm going to show this example in the later slide. And for critical path, should be no delays. There should be no delays, and delays is not acceptable. In network schedule, you can determine what is the early start, early finish, late start, late finish for each of the activity by using the forward and backward pass computation method. And by doing this, you can identify which are the critical activities, and thus you can also identify which are the critical paths. Okay, let's look at the important terms in performing the critical path method. Let's look at what early start, early finish means. This is a simple Gantt chart, consists of activity A, B, C, D, E, and F. Early starts means that the earliest time that an activity can start is determined by the latest of the early finish time of all immediately preceding activity, which means that early start of activity D depend on activity B completes. Once activity B completes at week 8, activity D can start. So activity D can start as early as week 8. And early finish of activity D is by adding the duration that requires activity to complete. In this case, activity D requires 2 weeks. So by adding 8 plus 2 weeks, the activity D can complete as early as week 10. What is late start and late finish means? Late start is the latest time that an activity can start without delaying the project completion, and it is by subtracting the duration from the late finish of the activity. So for example, in the same project, activity D, although it can start as early as activity 8, it can delay to activity 9. So by delaying 1 week of the starting date, it will not affect the entire project duration. So an activity D can finish as latest as 2 weeks, which is at 9 plus 2, which is week 11. And these are the latest finish that activity can complete. Later than this, it will affect the entire project duration. The next important term that you need to know is float. Float is also known as slack. It is an additional time available to complete an activity beyond the activity's work duration, which means that float is an additional time or extra time for an activity can complete. And float will not affect the project duration. For critical activities in a critical path have no float, so meaning there is no total float for activity that sits on the critical path. There is two types of float. The first one is total float. Total float is the total time available to delay the start of an activity without changing the project duration. It means that the project can delay the start, but it would not affect the entire project duration. And free float is the time available to delay the start of the activity without interfering the early start time of the activities that follows, which means, for example, you have activity B and C. Activity B can delay to start maybe by 1 or 2 weeks, but it will not affect the start of activity C. The next important term is critical path. If any critical activities is delayed in their start or finish time, it will affect the overall completion of the project. It means that whichever activity, the critical activity which sits on the critical path, if it delays, for example, whether it's delay on the start time or delay on the finish time, it will affect the entire or overall project duration. And critical path also can have the same early start, late start, and also early finish, late finish. And it also represents the paths which consists of activities that have no float, which means zero duration. I'm going to explain this later in the later slide. Okay, the next important terms is forward pass and backward pass. These are the computation techniques in order for you to determine what is the early start, early finish, late start, and late finish. Okay, forward pass is used to find the least time required to complete the project and the earliest time an activity can start according to the schedule that is being developed. Okay, let's look at this network diagram. Forward pass need to start at the left side to the right sides of the network diagram. And for each activity, beginning activity needs to start with 0. You can start with 1, you can start with 2, or you can start with 10, but it is best to start at 0. For each activity, early start, early finish is calculated by early start plus the duration, and you can get the early finish. In this example, the early start is 0. The duration for activity A is 2 weeks, and the early finish is by adding 0 plus 2 is 2. And in order to get the early start or early finish for activity D, is activity 2 plus 5, duration 5 gives you 7. Okay, for activity A, the early start is 0 and the early finish is 2. But activity D, 2 becomes the early start and 7 becomes the early finish, so as the rest of the activities. Okay, if there is more activities that terminate at the junction or node, for example, this node, this activity, where activity G and activity I terminates at one node, then you need to pick the larger sum, which means, for example, activity G, 9 plus 4 is 13. But you have to consider activity I, which is 4 plus 5 is 9. So the rules is you need to pick the larger number. So in this case, you pick 13. So that is how you calculate the forward pass. Now let's look at backward pass. Backward pass is calculated to find the value of latest time an activity may start or late finish time without affecting overall project schedule. Okay, the same example here, but for backward pass, you need to start from the right to the left of the network. So it means that you need to start here at 24. It ends at week 24. Therefore, for backward pass, you have to start with the same number, which is 24. So this is what we call late finish. Late finish is use the early finish for the late finish of ending activity. Okay, in order for you um, to determine what is the early late start for activity K, you need to subtract the duration from the late finish of activity K. So in this case, 24 minus 5 gives you 19. So it means that the latest that activity K can start is week 9, but the latest activity can finish is at week 24. The same technique or the same rules applies for backward pass. But for backward pass, if there is 2 or more activities terminate at the node, for example here, for activity I and activity J terminates at one node, therefore you need to take the smaller sum. So let's look at this example. 13 minus with 5 you get 8, but you have also to consider activity J. Activity J is 19 minus with 7 is 12. Okay, the rules is that when you do the backward pass, you need to take the smallest number. The smallest number here is 8. So that is why 8 is stated in the note instead of 12. Okay, to check whether your network schedule diagram is in a correct calculation, you need to end your backward pass with 0 too. So that is why I mean by start with 0, end with 0. It cannot be more than 0. If you calculate and you find that this box is not 0, then there is something wrong with your calculation, so you need to redo. So this is the best checking for your network schedule diagram calculation. Okay, let's look at the float calculation. Again, the same example. In this case, I'm going to focus on this activity G. Activity G, you have early start, late start, early finish, late finish for activity G. Okay, total float is where total time available to delay the start of an activity without changing the project duration, which means the project can delay the start but it will not delay the project. Okay, for this G, we look at the calculation. The method to calculate total float is where late finish minus the early finish. For activity G, the late finish minus the early finish, 13 minus 13, that is where you get 0. Or you can also subtract late start with early start. It also will get 0. So if you look here, okay, another example, activity D, 13 minus 7 is 6 and 8 minus 2 is 6. So it shows here that for activity D, activity D can start as early as week 2, but it also can start at as latest as week 8. So that is 6 weeks additional time. This is what we call total float. For finish time of activity D, you can see that activity D can complete at week 7, but activity D must complete at week 13, as latest as week 13. So that is another 6 weeks of additional time for activity D. Okay, let's look at activity G. Activity G can start as early as week 9, but activity G must start as latest as week 9. So there is no extra time. If you look at the finish time of activity G must finish or can finish as early as week 13, but activity G must finish as latest as week 13. So there is no additional time for activity G, either to start or to complete the activities. So this is why we say that activity with the total float of 0 is the critical activity. Critical activity means, again, that the activity cannot be delayed, whether for the start time or the finish time. If activity G delays either start or finish of the activity, it would affect the entire project duration, not just activity G, but also activity B and activity H, where the total float is 0. Now let's look what is free float and how to calculate free float. Free float is the time available to delay the start of the activity without interfering the early start time of the following activity, which means, for example, activity A the earliest that activity E can start is at week 7, and the latest that it can start is at week 13. So, but for activity F, it can start as early as week 15. So this means that although activity E can delay by 6 weeks, it would not delay the start of activity F, which is 15. So it means that the latest that the activity E can start is week 13 without delaying the start of activity F, which is 15. Okay, if you look at this diagram, the red arrow is represent the critical path. So as you can see that the critical path here where the total float is 0. The total float must be 0. Friends. And for your reference, critical path is where early start and late start having the same number, as well as the early finish and latest finish. As you can see here, all the early start, early finish, late start, late finish has the same number. To make you understand better on this topic, let's do some examples. For example 1, the network diagram has been drawn for you, and you need to calculate what is the early start, earliest finish, late start, late finish, and also to identify which is the critical path. So let's start with the forward pass first. Forward pass is where you start from the left side of the diagram to the right side of the diagram, and you need to add the duration of the activity. So let's start with activity A first. Activity A, let's start with 0. 0 plus 6 is 6, and 0 plus 3 is 3. 6 plus, in order to get node 4 here, you see that 2 arrow comes in to node 4. So you have to consider 2 value. One is from this direction and one is from the C activity. And also please note that the dotted line here means it is a dummy. Dummy means that you include dummy when you want to make the network diagram becomes more logical. I'm going to explain to you in detail what is dummy in the next class. So at the moment, let's take the dummy as a 0 duration. So 6 plus 0 is 6 and 3 plus 2 is 5. So as you know, when forward pass, you take the larger sum. So in this case, you take 6. 6 plus 7 is 13. And in order for you to get 7, not 7 here, you need to see there is 2 arrow terminates here. So you need to take the largest number. Largest number is 19. And let's move on to activity D, which is 3 plus 7 is 10. And before you decide what is the early finish for activity E, you need to also consider these two direction, these two arrow. And the first arrow is 13 plus 1 is 14, and 10 plus 1 is 11. Again, you have to take the largest sum, which is 14. So 14, in order to terminate here, we also need to take the larger number, which is 24. Now let's continue with the backward pass. Backward pass is where you start from the right side to the left side of the network diagram, and you need to subtract the duration of the activities. So let's start with the same value as you end here. So it starts with 24. 24 minus 5 is 19, and 24 minus 2 gives you 22. So again, as you can see at node 6, node 6 is there is two arrow terminates at node 6, so you have to consider two value here. So either from activity H or activity J. And as you know that backward pass, you have to take the smaller number. So 19 minus 6 gives you 13, while 21 minus 1 gives you 21. So the smallest number is 13. So 13 minus 7 gives you 6, and 6 minus 0, again this is two value, either you consider 6 or you consider 19 minus 4. So you take the smaller number. So in this case 6 is the smaller number, and 21 minus 1 is 22 minus 1 is 21, and 21 minus 7 is 4. Again, as you can see, node 3, there is two arrow terminates at node 3. Node 3 is where you see the smallest number. The smallest number here is 4, which is 6 minus 2 instead of 21 minus 7. Okay, and the last one is also you need to consider two value and take the smallest number, you get back to 0. Okay, so just to for your reference, the total float should be 0. So how do you calculate total float? The easiest way is to see the early start. This is the same value as the late start, or early finish the same value as late finish. So in this case, you can see that the early start and late start is the same value. All the same value here is considered as the critical activities. So when you have identified the critical activities, you can identify which are the critical paths. Okay, like I mentioned to you at the earlier start, the critical paths can have more than one critical path. So which means instead of A, G, I, you can also have A, the dummy, F, H, and I. Okay, I have also provide you with examples too. Examples 2 also needs you to draw the diagram and calculate what is the early start, earliest finish, late start, late finish. This time you calculate what is the total float and free float for each activity in the diagram, and also you need to calculate or determine what is the project duration. Okay, so this is the activity and these are the predecessor. Predecessor means an activity before this activity. For example, activity A and B, there is no activity before activity A and B, and these are the time of each of the activities. Right, so I have also provide you with the answer, so you can try to do this, and before you look at this answer, you can try to do it first and check whether your answer is correct or not. So now that you know what is early start, earliest finish, late start, late finish, free float, total float, the critical path, you can do this example 3 as a challenge for you, since example 3 is quite challenging, where you need to introduce a dummy to make the network diagram becomes more make sense or logical. With that, I end today's lecture. So stay safe and goodbye. Assalamualaikum.